Well, good afternoon. Thanks for joining and welcome to the irrigation webinar series. Today is the second webinar in a sub-series focusing on reading climate drivers for better farm decisions. And the focus today is using climate outlooks, forecasts and tools. My name's Rob O'Connor. I'm with AgVic out of Chuka, Yorta country. And Joe Braden is working in the background to keep this webinar running smoothly. Last week, we had the first webinar in this sub-series on reading climate drivers, and we had some key messages come out of that session. And one of the key messages was that key climate drivers affecting our particular patch are the El Nino-La Nina system, known as the ENSO, and the Indian Ocean dipole. These two systems both typically impact on our climate through winter and spring. There's different components to this ENSO system and the Indian Ocean dipole, and the activity or behaviour of these components affects the intensity of the climatic conditions that we experience, such as, how wet or how dry it is, or how cold or hot it is. Dale's historic analysis showed that there was a relationship between the climate driver events and the inflows into our key storages on the Murray and the Goulburn systems. So typically, with the higher inflows, we're experiencing a La Nina event or a negative IOD, and with the lower inflows, there was typically a El Nino or positive IOD event. Overall, a message was that active and informed monitoring of the key climate drivers, particularly through winter and spring, enables better anticipation and preparation for the upcoming seasonal conditions. And the recent rainfall that we've had in the last couple of weeks, amongst all the talk of El Nino conditions, is a really good example of that. So, the experience is that if you've been monitoring the climate drivers for a couple of years, you can develop skills in that area and become good at it, and be better able to anticipate those upcoming seasonal conditions. And some farmers have got quite skilled at that. Our next webinar is actually on in July, and that webinar is the new approach to delivery rights in Victoria, the place of take approvals framework. So many people won't have heard much about this new framework yet. It has been developed largely in response to the increased delivery risk on the Murray system below the Barmer choke. The new framework helps to protect irrigators to have their water delivered in times of shortfall when rationing might be installed, and it also when rationing is, and it will be a consistent framework set on all declared water systems across Victoria, including district channel systems. We're delighted again. Just a reminder, actually, about the questions. If you do have a question, please use the chat function and select co-host. Questions will be answered at the end of the session. There will be perhaps a break during the presentation, depending on how Dale is going. We do love your questions, as we love your feedback. And just a reminder, if you could fill in the feedback form that'll come up at the end webinar. And please remember to scroll down. There's more than one question on the survey. We are aiming to finish at 2 o'clock. So once again, we're delighted to have Dale Gray as our speaker in this second webinar. And Dale is a seasonal risk agronomist based at Bendigo. So over to you, Dale.
Rightio, thanks very much, Robbie, and greetings to you from Jara country, the ancestral homelands of the Jar Jar Wurrung people here in north central Victoria, where it's a toasty 9 degrees and the cloud is building, which is going to lock that warmth in, or the lack of it. What I will first want to start with this morning is just, or afternoon, we already had lunch, some of us, is just looking at just the basics of what climate models actually are and what they look like. So some of you wouldn't be surprised, I suppose, that the computer models around the world are based on maths, obeying the laws of physics, that hot air rises and hot air expands, and moisture, when it's pushed up high enough in the atmosphere, can fall out as rain, and if it's too cold it falls as snow, and that sort of thing. But what you've got in these models is that there's boxes. The model is made up of boxes, or cubes really, and there's boxes on the surface of the earth that, you know, work on the elevation and the land use and the tree cover and those sorts of things. And then you've got layers of atmosphere above that, and some models might have like 20 layers of atmosphere coming out from the surface. And then you've got undersea layers as well, and there might be, you know, 12 or 15 undersea layers underneath the ocean. Each of those need data in them to initialize the model. And so they are initialized with the current state, the known state of those parameters. What is the atmosphere? What is its temperature? What is its relative humidity? What is the salinity? What is the density? And where's the wind direction and stuff coming from? And so everything that gets pumped into the model. And so the model is a three-dimensional mathematical representation of the world. So it can't be exact. Nothing like exact. But this is just, you know, got all these different processes that are included in the model, obeying the mathematical laws of physics. And most of these models just could not give a rat's about what's happened in the past. All they work on is the data I see right now, and the laws of physics say this should happen from now on. If we go to my next slide, is that because we're talking about mathematics and every box in the world is a cube with the maths going on inside of it, there is resolution to the model, because depending on how big the boxes and the cubes are around is about the resolution of your model. So here's a couple of images here. This is the old Bureau of Meteorology's POEMA model. It's not that long ago that this was our official model. This is 2016, this graph was taken. And you can see that every square on that is an answer that the model has given for its area of the world. And those squares there were 250 kilometers square. That is what we would call coarse resolution. There are about 8 squares of answers for Victoria. Tasmania struggles to exist, and something like the Great Dividing Range simply doesn't exist either at that resolution in the world. In fact, the highest part in Australia was up here in the Kimberley or something. The new model of the Bureau has, which is AXSS, is a 60 by 60 grid. And so the resolution of that looks like this. This is the same mathematical input, and this is the resolution of the output that you get. You can see that that's a much finer resolution. There's a clear boundary in the Great Dividing Range here, because we know that's such a key feature of climate along Eastern Australia. And we've got a lot more squares, but they're still 60 by 60. And so when we look at somewhere like Bort, and the forecast for Kerrang says it's drastically different, you're going, why do I believe that when the model is 60 by 60 grid? I'd expect the data for Bort should be pretty much the same as Kerrang because of the resolution of that. Something strange would have to be going on, or very weird. climatically. And then we get to weather models, which I don't deal with a lot, but the weather models that go out to 3 days or out to 7 or 8, they might have resolution down to sort of 5 kilometres across Melbourne, or maybe 10 kilometres across Victoria. But all of them require a big grunty computer to run. And so model accuracy has been steadily getting better over time. You've got to believe me when I say that. And accuracy and model performance is 3 separate factors. And the first is just better resolution, more maths representing the world on a much gruntier computer. And so the bureaus of the world, they get big grunty computers updated every sort of 3 years, basically. Just the same as we're updating our own personal computers for the same reasons. And so you're able to represent smaller topographic features on the map and basically get a much more accurate representation of the world the way it looks. The other thing that keeps happening is that we have people in the world who get up every morning and they just want to make a better mathematical world. And bless their souls, because that didn't float my boat when I was in high school and uni. Maths and physics, but it floats theirs, and they're just trying to get better processes of the known world, and we keep getting improvements in that. The third thing is just getting a better actual initialization of how the world currently looks. It's not that long ago that the Bureau's model had a UK model for soil moisture across Australia, and now it's got an Australian model for soil moisture. And soil moisture parameterization, particularly at the surface, is really critical for things like temperature and humidity, and they can affect rainfall as well. So making sure your model is actually initialized to look like the world right now is really critical. And one of the difficult things is as you get better resolution in terms of the computer, you need better resolution of the ingested data to actually and run the computer. So, a lot of these models might be 1 million, 1.5 million lines of mathematical code. Sometimes they might take half a day or a day to run to spit out their answers. The other critical thing is when you're looking at computer models is, are they reputable? Because as I said, someone can jump on their old 486 computer and punch out a forecast on the web. But these computer models that we're talking about take supercomputers. They're massive and they are very expensive. And not everyone has access to one. So are they from an official Met department around the world? Are they a government authority or a university? And don't just presume that the forecast that you are looking at the web actually comes from one of those 3 things. It could be coming from somewhere else. It could be coming from a private company who's attempting to match it with these people. But this stuff does require a massive computer. And the World Meteorological Organization has a heap of centers in China, Italy, Brazil, the UK, and the UK as well. That's the EU and the UK, Australia, Canada, Russia, Germany, South Africa, Korea, Japan, France, and America. And they're the recognized centers for producing forecasts in the world, where we're talking climate forecasts here into the medium term, out to sort of 1, 3, and 6 months. Other things that are really useful, I find, about what makes forecasts better is just the extra bits that they add. Do they publish skill information about their model? And we're going to talk about skills soon. Do they publish how good their model is? Or is there no information whatsoever? Do they provide hindcasts? Can you go back to 1997 and look at what the prediction was and what the outcome was in the month of spring? Because that sort of stuff's just gold to be able to go back to historic years and go, this model absolutely nailed that. I wasn't around at the time. The model didn't exist at the time, but if it did, it would have absolutely nailed that forecast. And that's really helpful. And that sort of data is actually essential to develop the accuracy information. And some models provide really useful commentary. Our own Bureau of Meteorology provides amazing commentary about what the climate state is, what the models are saying, what models around the world are saying, what their model is saying. And most people just don't even hear that. They don't read it. They don't know it exists. All they get's the 30-second grab off the news, which generally tells you the most useless or least helpful bit of information. So let's look at a forecast here. I'm going to talk about different types of forecasts. The majority of climate forecasts in the world are probabilistic. And that means they're talking in terms of probability. The model is not saying this will happen. It's saying this could happen and the opposite might happen as well. So this is a current forecast for the next 3 months. And, you know, if you just didn't know what you're looking at here, you'd be looking at that and going, gee, there's a lot of brown on that map, Rob. That must be saying it's not going to rain at all. And if we actually looked at the scale, we're going, there's a 20% chance of exceeding the median. And it's important to remember that by definition, that means there's an 80% chance that we're going to be less than the median or less than the average. This forecast does not say it won't be raining. It doesn't say there's a 20% chance of rain. It's saying it's a 20% chance of exceeding average, which is not a very high chance. It doesn't, however, say that it can't rain. We often see the white forecast, so somewhere over, well, it's a bit hard to know. I can't name a location anywhere in there. But the 50% forecast, which we often see, is that 50% chance of exceeding the average. But that doesn't mean we expect average conditions. It means we've got to expect anything. It means there's a 50% chance of drier and a 50% chance of wetter. It's the plan for anything forecast. Now, our own Bureau, I reckon, has gone from having some of the, well, let's not, Mickey Mouse would be wouldn't be fair commentary, but simplistic forecast information to easily now having the most information about their model anywhere in the world. No one provides anything like this now. Most of this came out last year or the year before. A lot of people, I suspect, have no idea that it even exists. So here's the map here at the moment I just showed you, where you can go in and punch in the name of a location. I punched in Falls Creek up in the catchment, and you now get a decile chart showing that out of the last 99 model runs, where did they bin in terms of the decile rainfall output? And you can see that, well, there's a few of them. 5% of them have come in at decile 9 and 10, but 54% of them have came in at decile 1 and 2 in the drier end. This is a warts and all forecast here. This model will not be wrong, Rob. It will be, the answer is somewhere here. And at the moment, the probability says we're expecting things up here in decile 1 and 2 from this model. The other thing that we can do is look at a time series over both weeks and months of where the spread in a box and whisker plot falls over the coming months. This is the only way you can look at the Bureau's model output into five whole months there laid out. Most of them, at least at Falls Creek, sort of sitting in that kind of decile 2-3 range, 3-4 range. But the probability of getting 4 decile 3-4 months in a row puts you in a decile 1-2, because that's actually not very common to have so many slightly drier months. You can get information of the skill of the model. If you're a real nerd, you can get a probability or a probability of exceedance function. And that's probably the most complex thing that now is available, but you might be sitting there and thinking, gee, I could really do with a probability distribution function of where the rainfall is likely to fall in the coming months. Or the other thing you've got is a burst product here, which is the chance of getting a certain amount of rainfall in just a 3-day period. And this is, I just plugged in 25 millimeters here for 2 weeks from now. It only goes out 1 and 2, 3 weeks, but there is in fact the chance of getting a burst event of 25 mil at that time, but not out anywhere else, not where else we're not really wanting to see much out there at the moment in terms of an inch. But that it could be an interesting product for people. This is just a map showing the chance of getting decile 1 to 2 spatially across Australia or just Victoria. This is the chance of getting decile 9, 10. And you can see that, I think that forecast is for next week. There's a chance, actually it's not next week, it's this week. There's a chance that West Gippsland is in the money for higher probability of wet rainfall, decile or decile 9, 10. So all this stuff's now available. It's available for weeks, fortnights, months, and seasons out to sort of 4 months and even 5 months if you go with this product. And that's for rainfall. And you can do the whole thing for maximum temperature and the whole thing for minimum temperature if you're so excited. So incredibly powerful tool there. Let's look at a different way that world climate models present data. This is the Bureau's model, which they don't present their data like this, but I get access to an experimental one that does. This is called a tercile probability. Tercile means 3. Divide the data into thirds. And if you look at all the data historically, rank it from lowest to highest, a third of it is what we classify as dry, a third of it is average, and a third is in the wet end. And what happens in this one is you run the model 100 times, or in this case 99, and you bin them in. And that's saying that, Mount Buller here is in the 70 to 80% chance of being in the driest third. That's a very different bit of information than lower than the median. Very much so. It tells you a lot more. And normally there's a 33% chance of dry. So a 70 to 80 is a greater than doubling of the odds of being in the driest third. But that still means 20 to 30% of those model runs have fell in average or wetter. And that, of course, could in fact happen, but just at a much lower probability. Here's another way models present their information. This is the ECMWF's model. Same thing with the tercile. It's just that they've just got white. The white means is the normal. So white's the third. Anything could happen rather than average is most likely. And we've got a forecast here in the, it's actually in the 50 to 60% chance of being in the bottom third of the bottom lower tercile, the bottom third of records. I think people get a bit hung up about, how much percentage here, how dark it is. My experience over 17 years of looking at this stuff every month suggests to me that just a sniff of drier is enough to set the cat amongst the pigeons that in fact it could be dry. We've, all through the millennium drought, we had models sniffing drier, but not necessarily going crazy, towards the end of, really high amounts of model runs looking dry. So I often say this is the Dennis Denuto effect. We are looking at the vibe of these models. We are not looking at specifics. Which is interesting because there are models that do give you specifics, and they are what we call deterministic. And they run their model and they compared the rainfall that falls in a box and they compare that to average, and they give you an anomaly of rainfall. And so this is the American NCEP, American Bureau. And so it's saying here that southwestern Victoria for the next 3 months is going to be 1 to 0.5 mil less rainfall per day for that 3-month period. And just going, whoa, what's that? I mean, I've done the maths for you. That's 47 to 94 mils less in the next 3 months. But once again, I wouldn't be getting caught up in how many millimeters less is that. That's a forecast. It's sniffing drier for the southwest, but over the majority of Victoria, that model is sort of saying that anything could happen. Here's another deterministic model. This is the BCC, the Beijing Climate Center from China, presented slightly differently. And this is a percent anomaly difference. So they're saying that Victoria's looking like being 10 to 20% lower in rainfall over the next 3 months. So that's just the different ways that a lot of different models present their information. But once again, don't get too hung up on the numbers. I tend to broadly rank things in 2 ways. Is there a movement away from 33%? Is there a drier or a wetter sniff to these things? And then is there doubling of the odds? Once they get above 66% chance, I then say, well, that's a more emphatic model. 2/3 of those model runs are coming out in the driest third or the wettest third of records. And I think that sort of means more than just a bit more than the third. Means the model is being more emphatic. So I've talked about accuracy. Scientists use the term skill to describe the accuracy of their model. The two words are interchangeable. And the reason skill's really critical, but some models don't present skill because to actually do it is no easy task. You have to initialize your model with the data for the previous 30 years previous on, well, if not a monthly basis, maybe a weekly or daily basis. And so that is not easy at all. And so we run the data for September 2010. We've got the world set up and we give the model a little nudge and let it go. And it comes out and says it looked like it was going to be wet, probably. And then you do the stats on that and you go, well, it said it was going to be wet and look, it was wet. Tick, 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 model's done well. So it's really interesting. Lots of different places use different stats. There's no consensus of the way people do this sort of stuff. And they make maps and graphs and, you know, they torture this stuff to see if this model is better than flicking coins. Is it better than chance? So this is the old Poema model. You can tell that because it's got that same 250K grid. This was the skill of that model in summer, autumn, winter, and spring. And you can see that at certain times of the year, that model had no skill in much large areas of Australia. And that spring was its purple patch in eastern Australia. And, you know, there was only one area of Queensland there where that model had high skill at any time of the year. I can't remember what the actual measurement was that they were using here. Anyway, it doesn't matter because this model doesn't exist. This is the new model, Access S2. And this uses a weighted percent consistent skill score. I'm not going to explain that because I couldn't even try. I just tend to go with the color schemes work pretty well here. And the numbers, so above 50% is better than flipping coins on this scale. And so you can see we have different ratings of green, and we have, you know, areas of 75 to 100% accuracy. And occasionally in spring, you know, Western Victoria has very high accuracy, Northern Australia in autumn, Central Victoria in winter. But everywhere this model has skill. This model was a vast improvement over the previous one, which was a vast improvement over the old statistical system that we used to have previous to that. This is an assault to the eyes. This is the ECMWF's model. This is their way. They're using a thing called a ROC score. I can't even remember what ROC stands for. If you really want to know, I could look it up, but it doesn't really matter. And once again, if you're in the yellows and the oranges here, you've got good positive skill. If you're in the blues, you've got negative skill. I'm not even sure what negative skill is, to be honest. You're getting it wrong and really, really wrong, I suspect. And you can see here that Eastern Victoria's got some skill in this model, and with this is starting in June for the months of July, August, September. Queensland, New South Wales, South Australia, but once again, southwestern of Victoria there, sneaking into the Mallee, has a bit lower skill. But you can also see that the squares on these boxes are, well, they're relatively small, but they're not massive either. So the resolution is often sometimes pretty coarse on these skill charts. This is one of the favorite ways I love because you don't have to care about the statistics. This is the NOAA NCEP American Bureau model. Here it is with its slightly drier forecast for Southwest Victoria. And let's just remove the areas for where they've no skill. Make them grey. You can't get a forecast. It doesn't exist. So this is called a skill mask. And so we can see that, you know, large areas of Victoria and the world, for instance, have skill, but there's very large areas towards the poles where the model skill is rubbish. And so you just don't show it. I have it on reasonable authority that our own Bureau is going to be looking at demonstrating something like this on that first map that we see, that you can very quickly and easily toggle off where is the skill, where is there none, which will be a fantastic thing. I showed this image last month. So not only is there model skill, but that model skill is also seasonal. And it's really due to the fact that the climate drivers are active at certain times of the year, influencing rainfall, and at other times they're not. Or they're much more abstract, or for every time they've been wet, they've been dry. And so model skill over summer and into autumn is classically not the best. And then winter, and particularly that late winter looking at spring, is the purple patch for model performance. I want to show another tool. Last week I showed a heap of data about, torturing rainfall, and in fact, and also data sets of inflow into dams according to what the climate drivers have been done. This is just a website that I helped develop some years ago. It's called the Local Climate Tool. There's the link, and it was set up for cropping areas, Robbie. So you can't see all the areas you might be interested in seeing. But what this shows is those tercile pie charts of, if you pick a climate driver, in this case El Nino, for the months of, I can't see because I've got something blocking that. I think it's August to November or something like that. At Omeo, what's the chance of the rainfall being in the bottom third? So that classic tercile pie chart. These are the decile rankings for the rainfall historically for all these different climate drivers. Once you get an El Nino, it's almost a 33% chance that it's been decile 1 at Omeo when you've had, that's El Nino plus positive ID, sorry. Where's the El Nino one? That's up there, yes. So El Nino positive ID, similarly, combine the two at Omeo, you get a much stronger response, but not as many years in the record. Another nice way of demonstrating all the different climate drivers. Apologies if you are colourblind. I suspect that might be a challenge, although my boss is red green colourblind and he seems to find this no problem. But you rank all those things from lowest to highest, and you see how the colours generally migrate towards the drier and or the wetter end. But they show, once again, individual years, and you can highlight these on the website. Bring up that individual year there. What is that positive ID that was so wet? What's that La Nina here that was so dry? And have a look at them. The other thing is, you can just warts and all look at all the monthly rainfall, how it's fallen out in that pie chart, and just look at, well, actually, how many of those have actually been really dry, where I'd say that was terrible, like I did last week. And shows that 10% to a quarter of the time, some of those climate drivers have been absolutely horrifically wet or really nastily dry. But it's, these things do, El Nino doesn't equal drought and La Nina doesn't equal flood. And this data is just a fantastic way of representing that. Robbie asked me to put this slide in, and I'll try and do some justice to it. The climate drivers and information about climate drivers is used in marketing, and the water market is no different. And we see information about climate drivers affecting sheep markets, beef markets, grain markets around the world. As when someone starts making a prediction of something, people start to factor the possibility of that into the future. And when it starts to actually happen, well, a lot of that price signal is perhaps already captured. We can see here the blue is just the Southern MDB storage amount, volume in percentage. And we've got years going back, so coming out of the millennium drought, pricing in purple. So low amount, higher pricing, not rocket science there. But often really very rapid declines in price sometimes as soon as things start to swing out. So once in November 09, I'm not sure quite where the months actually line up here, but once we came into 2010, water availability went up and unsurprisingly price went down. But often the signal happens way before the dam actually starts to fill. And 2015 drawdown there, and then the 2016 negative IOD wet, and the price, very quickly, it started to come back after that, way before the dam has got full. And then obviously things have changed since March 09, November 19. We've got price going up, volume similar, well, a bit better than what it was back in the Millennium Drought, but not amazingly so. Pricing way in excess, clearly, with all that perennial hort demand that has increased over recent times. So Robbie did actually want me to just give you an update. How we're going for time, right? Just an update on where we're sitting right now, because that is quite fascinating. And if you've been watching the media, you'd be looking at your rain gauge and going, what is going on? We actually have an El Nino out here in the Pacific at the moment. We've certainly got an El Nino off the eastern coast of South America. And as of the last couple of weeks, we've got a weak El Nino happening out here in the centre of Australia that affects Australia the most historically, and that's in that Nino 3.4 region here. The value there is plus 0.89. The value that Australia puts on an El Nino is plus 0.8. The American Bureau puts a value of plus 0.5. I think I explained that last week. So they were calling it way before us. And as you'll see soon, the Australian Bureau is still not calling it, and you'll see the reason for that soon. Over in the Indian Ocean, warm ocean happening over here, normal to warmer ocean happening in this box. The dipole mode index is currently sitting at absolutely 0. That doesn't quite look like that for my money, just that. And it's important to note that this data does not come from this imagery. So the different bureaus of the world, this is an American image with an Australian data analysis. So we're always comparing the same things. But there are interesting things here. So we've still got this massive warm amount of water up here in the Coral Sea, completely unlike recent El Ninos. We have, however, seen progressive neutralizing and weak cooling of the water up in the Timor Sea and off Java. And for my money, this is the bit that's probably more concerning at the moment than what's happening out here. The El Nino out here is having to compete with a really abnormally amount of water up here left over from the last 3 years of La Nina. And for that money, the El Nino is finding it really hard to behave itself. It would classically do. At the moment, the Indian Ocean is completely normal, but I'd be watching for any further progression of blue into this box here. It's interesting, it's slow, because as we'll see, there's no real underlying reason as to why things should be necessarily cooling down up here at the moment, even though, as we'll see soon, every model's predicting a positive IOD, so cold in this box, warm in this box, and an El Nino, which we currently do for at least the next 6 months. The underlying signal of temperature under the ocean is interesting. So the pink line is where the ocean is completely 0. It's completely normal in temperature. We've got really warm water to depth underneath the Pacific, underneath the El Nino, as we would expect. We have this massive amount of warmer water to depth underneath the warm surface, which is completely the opposite of what you would expect for a La Nina. In fact, if we get the water in this area to upwell colder with reverse trade winds, it's hard to see where the colder water is coming to the surface. It'll be colder than normal, but it's not going to be as cold as it looked in 2015. Everything to the north of Australia is slightly warmer, but not excitingly so, but essentially slightly warmer. Things are warmer under the sea off Sumatra and colder under the sea off Africa. This is the exact opposite that you would expect for a positive IOD. We'd expect cold underneath, which it was a couple of months ago, and warm underneath here, which it was a couple of months ago. But the models, even though they've seen that, have not changed their stripes. So it's confusing me. I'm not quite sure what's going on there. It must be just surface stuff going on, which is, usually these things are phenomena that occur at the surface and the depth. Cloud patterns. The international dateline junction with the equator, normal cloud there at the moment. Had been an abundance of cloud for 3 years almost with the La Niñas we had. Large amount of cloud in the Coral Sea over the top of the warm water. That's still very much a hangover of the La Niña and remotely unlike El Nino. And we've just got a complete lack of cloud over the Indian Ocean. And I'm not sure what to think about that. I'd rather see an abundance of cloud. I'd rather see something going on. But there's no differential here where we'd see an eye of a lack of cloud off Sumatra and an abundance of cloud off Africa if we had a positive IOD, which we simply don't at the moment. So we do, however, have a lack of cloud in a northwest-like trajectory going over southern Queensland, northern New South Wales, as we would know, are not enjoying the start to the season that we have had. This is the wind direction and speed anomaly. The arrow shows the wind direction. The colour shows how much faster it's going compared to normal. The winds along the equator are just completely normal. If we were going to see a proper El Nino, we'd see reverse trade winds, much stronger in this box that I've circled red here. If we had a positive IOD or wanted to see the formation of one, we'd expect much stronger easterly winds off Sumatra out towards Africa. And we don't see that either. So in terms of the winds, they're not playing ball. They're not interested in being El Nino or positive IOD. And until they do, it's unlikely, I think, that we'll actually see proper formation of those two phenomena. And yet we've been enjoying good rainfall. So the first thing is that we don't have a proper El Nino, we don't have a positive IOD, so there's no reason why it can't rain. Absolutely none. Even though every model's been predicting it to be drier, nearly, that would be predicated on the fact that those two climate drivers actually were forming, and they simply have not yet. Because what would cause these reverse trade winds and the winds up here will be elements of weather. There'll be tropical disturbances up here that can cause this reverse trade wind and flip the pattern into something that's a positive feedback loop, gets it to feed off itself, and the system will be humming for many, many months once that happens. But you need something to kick that off. It just doesn't suddenly happen. And that thing is a weather phenomena. It's often a thing called the Madden-Julian oscillation. But it's essentially been, the Madden-Julian oscillation's essentially been missing in action and not very strong in the right places to get these things to actually kick off. The Southern Annular Mode is that measure of climate around Southern Australia. It was essentially behaving itself at weak positive, negative, just bouncing around over every week or two, such as its wont was in autumn. It went through some negativity in April. In the first 2 weeks of May, we were wondering how we were going to buy a rain. It went incredibly strong, which meant the frontal systems were dragged south of Australia. And then in this month, we've had a burst of moderate negativity, and that's been pushing the frontal systems closer to Australia, and we've been getting, at least north of the divide, one every 3 days or so. It's not high rainfalls sometimes, but just little showers, keeping things damp. The next 2-week forecast from both the American and Australian bureaus is that it's going to come back to normality, and pretty much the American bureau sort of does a bit of a negative burst. The Australian bureau sort of holds it around normal. The other thing that's been occurring is the pressure patterns have been very unlike El Nino and positive IOD as well. If we look at the centre of high pressure patterns, that's almost been at the Queensland-New South Wales border, where in the middle of winter, we'd expect the ridge to be sitting at the top of the bight. What that's meant is that everything has lifted up, and it's allowing those fronts and things through with great monotony because everything's lifted up, and it's not giving our colleagues in southern Queensland and northern New South Wales any joy because the block is sitting right directly over the top of them. But we're enjoying all this frontal stuff, not getting fabulous connections to the tropics. We did a couple of weeks ago when we got the big rain across many parts. But because the Coral Sea's so warm, we can absolutely still get a connection to the tropics that's really quite good. because, yeah, nothing really busted up there to the north of us at the moment. And in terms of allowing systems through to cause it to rain, well, that's actually been enhanced. So that's why we're seeing the way we are. If we look at absolute pressure, we've got lower pressure over southern Australia. You know, there's basically been more frontal systems through as everything's pushed further north. And because of that, we've seen pressure increase at Darwin. The pressure at Tahiti is normal. That's why the Southern Oscillation Index is negative. It's at -14. That's an El Nino-like value for the pressure patterns. We can see that there is broad lower pressure everywhere in the South Pacific, which is consistent with El Nino. It's just not quite exactly at Tahiti, but it's close enough. And this whole issue is that once we get pressure building to our north, it's often harder to drag moisture down. It's like pushing water downhill. And we can see there's just generally higher pressure everywhere over that lack of cloud that we see over the Indian Ocean. So it's a general lack of moisture pattern out of there, but it's not a positive idea. It's just a lack everywhere. This is the bogey, big red high pressure sitting out here. And it's the case of, I suspect, if or when this high pressure moves over us and we start to see the end of this frontal stuff that's going on, is when we will start to see a drying pattern, if that is going to happen. So that's something to watch. It'll be the signal that the game may be changing. So forecasts from June, seeing them here, almost first really. Every model is predicting an El Nino. Well, we have one, so that means that's interesting. It's keeping it going for 3 months. Every model is still predicting a positive IOD, even though we don't have one. And they've been doing that for a number of months now, and it's not happening. So that is a bit bizarre. Almost every model, bar one, predicting that the outcome is likely to be drier. So plenty of models predicting a greater than 33% chance of it being in the driest third of records, but some models like the Bureau and others, China, UK Met Office, a collection of world models here from the Asia Pacific region, have got greater than 66% of their model runs coming out in the drier end of things. Just about every model predicting it to be warmer. So at the moment, you'd say this model here is, well, it's sitting on neutral. It's the only one that's all year not been jumping on the dry bandwagon, but it's performing. It's the closest you're getting so far, but time will tell, I suppose, as to whether that continues on. If we go out to the real crystal ball, gazing out to late spring, early summer, the El Nino's continued on. The American Bureau's killed off the positive IOD, but everyone else is keeping it going. The predictions are still for drier generally from nearly all the models, bar that American Bureau, and for warmer. But I'm at pains to explain that these drier and warmer forecasts are on the basis of these two climate drivers forming. And at the moment, I'd say that battle between the Pacific Ocean and the Coral Sea, you know, it's going to be interesting who wins that, because at the moment they're not winning. Well, the Central Pacific's not beating the Coral Sea, and in the Indian Ocean, well, nothing's happening there as yet. It's important to note that the Indian Ocean could flip in the space of a month. That's how that would be as short a time as it could take to get that to change. Whereas an El Nino, once we've got one, you know, that's not disappearing next week. It's taken a number of months to get to this stage. It takes a number of months to wind it down once it's got its pent up emotion going. So just a little summary page here, which kind of shows where we're kind of at with these two climate drivers, which can cause it to be drier. But, you know, the surface, the depth and the pressure is all very much El Nino-like, but the winds and the cloud patterns are not. And the wind pattern in particular is what's going to drive the colder water to the north of Australia. And so if we don't get any reversed trade winds off the Solomon Islands, we're not going to see any colder water welling up there, and the Coral Sea is going to remain warm and a moisture source. It's kind of at odds to what the El Nino would normally be trying to do. Out in the Indian Ocean, well, it's really, you know, that sea surface that is vaguely looking a bit positive IOD like? The ocean depths don't look like it at all for my money. And the pressure, winds and cloud, even though they have perhaps a drier tendency over the whole Indian Ocean, are not looking like that climate driver. So just in summation, know where your forecast is coming on. That goes for weather forecasts as well as climate forecasts. You cannot presume when you're looking at this device here that it's coming from the Bureau of Meteorology or even the American Bureau. It could be coming from a private company, which may or may not be a better model. And most likely probably is not a better model. The model skill is highest in winter and spring, and always look to see if you can find skill. When you look there at my forecast, I actually provide skill information here for the 3 months ahead from the different models that provide it. So you can see where there's an empty box here are models that don't provide any publicly available skill for me to look at. Most models are probabilistic. The odd one is deterministic, giving you a dry, how much wetter, how much drier. Neither is better or worse. Once upon a time, I used to want more deterministic models and less probabilistic. I've since come around to think that probabilistic's probably better. Ideally, some models provide both, and I reckon I really like it when that gives you both things to look at. Despite the predictions for positive IOD and El Nino, the Indian Ocean just sits there doing not much at the moment, but still warrants close monitoring in the coming weeks and months. The Pacific Ocean is not a fully coupled El Nino at the moment. The atmosphere is not talking to the ocean, and until it does, we won't see the classic response I would expect. And the pressure and frontal patterns have been very favourable in keeping us in the game, but often that is a temporary thing, that you would need a negative IOD or a La Nina to be in existence to keep that kind of pressure frontal pattern going over the rest of the year. Seeing it for a month can often be sort of a flash in the pan until something else appears. So that's it from me, Rob. Happy to take any questions if there are any from the floor or from the comfort of people's kitchens.
Thanks, Dale. You certainly covered a lot of ground there. That's a lot of valuable information. We do have a number of questions. One here from Andrew. How do you interpret high-low pressure areas? If you look at a low pressure area, do you think rain? Do you think wind direction or something else?
Yeah, so it's kind of a bit of all. It's not a direct correlation necessarily between low pressure and rain, but it does mean you've seen more rain inducing triggers. So you can only get lower pressure if in fact you have a low pressure system, particularly in this kind of purple color here, which is the lowest it kind of gets in terms of the anomaly. And you get a lower pressure, obviously, every time a front passes by, and then it recorrects itself and the high comes in behind, it goes back up again. So what this tells me is we've been seeing more either fronts or low pressures or both. You kind of need to have watched the weather patterns to know exactly what has come from that. Doesn't really tell you about prevailing wind patterns. This one here tells you prevailing wind pattern. That's the average synoptic chart. So that shows it's been westerly across Victoria in the last 30 days, essentially, which has mean there's been plenty of movement of frontal systems in that westerly flow. It's very different when you're in a high pressure sitting over the top here and you've got a north westerly flow coming into Victoria. You're not going to get rain when that happens. So sometimes this one tells you a little bit more than the anomaly. I really like the anomaly though about the higher pressure in the tropics, particularly from now on over the non-wet season, really tells us something about the ease of getting moisture down. And that's essentially how El Nino and positive IOD do their dastardly business, by either increasing the pressure to the north or by increasing the pressure in the south, and by changing the temperature of the ocean. So they change the moisture source and they do something about changing the availability of the rainfall triggers that are coming across. Good question.
Thanks, Dale. Yeah, as I just mentioned, covered a lot of ground, a lot of sort of outlooks and forecasts and tools and models, which is great. It's quite a bit for the average punter to sort of process and follow and monitor. Is there particular bits of information or publications that people might get most value out of?
Well, I'd thank the member for Echuca for his question. I would be biased and say that my newsletter, The Fast Break, that comes out once a month, which summates that, which is where that table comes from, comes out once a month. I've been doing that every month for 17 years. Gives you a fair idea of where models are or are not heading, and what they're predicting for. Well, there's four states of Australia at the moment that's done for. South Australia, Victoria, Southern New South Wales, and Tasmania. The other thing, though, is that the Bureau of Meteorology puts out, once a week, once a month, it puts out a climate note where it's, it actually talks about the reasons the forecast is what it is. And it's classic gold to read it. You'll never see what's in that printed in the media. And it's not dry reading, but it often tells the warts and all stuff about the model saying this, but we're not really convinced of what it's doing because other models are saying something else, or things are at a time of the year where we would, the skill is low, and and perhaps take this with a grain of salt. But that's the stuff that doesn't get into the media, but it comes out every month. Get that sent to your email box. People are looking for those. Like, there's so many links that you could provide. I didn't provide many, in fact, because there's a gazillion. But we do have a link page on our own website which links to a whole heap of those different charts and models. If you really wanted to go and have a look at them yourself, you could. But that one page of all the model summary saves the average punter probably a couple of hours of web searching, I suspect, on an A4 page.
Is there an easy way to access that BOM note that you just spoke about, Dale?
Well, it is on the. It's funny because the BOM's climate page is on the bottom of their website. You'll see the little word climate, and if you click that, you'll go to all the historic climate data and all of the forecast climate data and all of the climate change data as well. There's probably more information in that little section than on any other section of the Bureau. But in particular, just hitting on climate, you go to the forecast page, and then you can see the links to get to the actual feedback notes and get on the email lists and stuff when they come out.
Fantastic. And I think this will probably be the last question given the time. Just like the climate map you put up, the coloured map was showing about an 80% chance, 20% chance of exceeding median rainfall. So it was brown around northern Victoria, which is pretty low probability given the uncoupling of the atmospheric conditions. Would you like to comment on that?
Well, it's puzzling and perplexing, but that model is not alone. There is at least 4 to 6 other world models that are not genetically connected that are going the same way, and yet locally we see Australian patterns are different. And that's probably why I'd recommend going to that new climate web page and looking up the week forecast, because when you look at the week forecasts out for the next 4 weeks, that has a different story than the next month. So yeah, and we've been seeing that. So the forecast that looks out to 3 months at the end of the month, it predicts the next 3, and it goes, gee, it looks like it's likely to be drier, and quite certainly likely to be drier. And then you get in and you look at the weekly forecasts, and they'll show a bit of a chance of wetter across Victoria for a week and a bit of normal rainfall in another week. And you're going, wait up, the weekly forecast is not adding up to the forecast for the next 3 months. So what we're seeing, I think, is that the overarching climate is set up in such a way that it should be going dry, but the weather is mucking that around, and we are seeing rain-inducing weather coming across Victoria that would seem to be having no predictability, which I find that puzzling, except that they think that low pressure and the frontal things coming in the southern annular mode is not going to be as, it's going to change. Now, until it does, I'm not going to believe it, Robbie. I'm a man who's looking for evidence rather than model predictions. And at the moment, we've got model predictions, but scant evidence that those climate drivers and systems around us have changed to the drier. Some of them have made a move, but they certainly haven't locked in. And I think we said this last week, Robbie, it's important to say that when the bureaus of meteorology of the world declare an El Nino, it is not like a tap. It's not, Bureau declares it, suddenly stops raining. That's not the go at all. The Bureau will declare an El Nino when that wind pattern and cloud pattern and stuff starts to look like it should for a proper event. Because until it does, we kind of don't have one. Yeah.
Thanks, Dale. And that's probably not a bad note to finish up on. And I think it just sort of goes to show that we do need to, if we want to be properly informed about what's coming up with seasonal conditions, we do need to dig a bit deeper than just the outlooks and looking at those things you've been talking about, like the climate drivers, what's going on there, and some of those tools that you discussed, like the forewarned is forearmed, and the weekly forecasts that you spoke about just then can provide a lot of good extra information, as does the BOMS climate driver updates and the break newsletter and video. So special thanks to Dale. I think we could explore this topic a whole lot further, Dale. There's so much in it and so much value. But thanks very much for fantastic presentation. It has been very good value. Thanks to Joe again for his work keeping the webinar running smoothly, and a special thanks to the webinar participants for your support and contributions. Please don't forget the evaluation poll on your screen and to scroll down for more than one question. Yeah, have a good afternoon, and look forward to seeing you at the next webinar in July. Thanks very much. Bye.
All the best. Thank you.